Hi students, good evening to all of you, and yet we are here today for another interesting session that is on rotational motion. Now rotational motion, I know that it is one of the most dreaded chapters when it comes to the preparation, whether you call it the board examination, whether you call it the JEE mains or the advanced or NEET examinations. Now, I have got some really interesting questions for today's session. So, we will not take much of time in the introduction and right away go to my today's session. So, all you students are all geared up for today's session? Fine. So now let's go ahead and discuss some of the very important things before we can get started off with our today's session. Students who are watching me live on the JEE English platform for the first time, my name is Sumit Kundu. I'm a BTech graduate from IIT Bombay. I did my civil engineering, BTech in civil engineering, and my rank was 2125 in the year 2003, way back. All right, so it has been a number of years, and in these years I have trained, coached, mentored, guided so many students successfully. They have secured a very good rank in different examinations in the country. Now it gives me a pleasure to be on this awesome platform, that is the Unacademy platform, so that I can reach out to maximum students in this nation, also across the seas, those who are preparing, let's say from Dubai, Oman, Muscat, any other place. So you guys can watch me live every evening at 5 o'clock to 6 o'clock. All right, from 5 o'clock to 6 o'clock with your JEE sprint sessions. All right, now let me tell you students, we are also coming up with something really very interesting. All right, so I want all of you to stay tuned to this channel. We are going to have some really very good value addition courses that will be launched live on this particular platform. So do not forget to subscribe to the channel, because only then you will be notified whenever we are coming up with something interesting, something motivating, something that will be remembered by you students till the preparation of your competitive examinations. All right, so what do we have next? We have the JEE Mobile, tinyurl.com/JEE Mobile. Now here in this particular URL, that is the website, if you go to, entire year's lecture is basically there in the archive format. So if you have missed on anything so far, go to the channel, go to the link and explore for yourself, and you will find more than enough for you out there. And remember students, all of these things are basically free. I mean, you are not being charged by anybody in order to access this particular website and get a tremendous amount of value addition in your life. Okay, now few important things. Students who haven't taken the Plus subscription so far, all right, students who haven't taken the Plus subscription so far, please use the code SMLIVE and right away get a 10% discount. That means you don't have to pay 32,400, instead 27,000 only. All right, students, where there are coaching institutes who are charging you bomb, all right, in order to get similar benefits, I mean similar services to be given to you, it's only 27,000 rupees. All right, so we will go ahead to our first question. Students, are you excited? Are you excited? Hi Om, hi Mitesh, hi Ravish, hi Abhishek. Good evening to all my students. All right, the amount of excitement that I am having right now, I can't even express, because this is one of the most dreaded topics. All right, and I have handpicked some of the very interesting questions. All right, some of the very painful areas of students where they actually face a lot of trouble in solving those kind of questions. So here goes my first question. What is my first question? I have got a thin rod which is of length this is let's say this is my thin rod. I mean, this is a small one. So let me take a bigger one. Just visualize it. There's a big rod of length 4L. All right, and it has got a mass of 4m. Fine enough. Now what we are doing, listen to it very carefully. We are bending it in form of a W. We are bending it in form of a W. Now it has been asked that we need to find out the moment of inertia of this entire shape about this particular fixed point. So this is the fixed point about which I need to find out the moment of inertia of this body. Now, how do we do it? Now, remember one thing, students. All right. See, in JEE, nobody is going to ask you what is the moment of inertia of a sphere or a disc or a circular ring and things like that. But it is going to be a combination of multiple things. All right. And most of the questions that we have come across in the previous years, what we have seen is that application of either the parallel axis theorem or the perpendicular axis theorem is definitely going to be there. All right. So if you haven't done that as yet, please go ahead and do it. I think it's a very simple concept. All right. That is nothing but moment of inertia about any axis is equal to the moment of inertia about the center of mass plus m r square, where r is the distance, or let's say instead of mr you could actually take md square. Rather, it will make more sense to all of you. So you could take md square, where d is the distance between the axis and another axis which is passing through the center of mass. I hope all of you people know this particular rule. All right, now let's go ahead and solve this question out here. It's not a very difficult question. I also recommend you students that if you are actually watching this particular program live, all right, sit down with a pen and a paper, because as long as I am doing the question, reading out the question, you can solve it for yourself and give me the answers right out here. All right. Yes, some of you, as I can see, Mitesh has given the correct answer. Good job, Mitesh. All right. So for all of you other students, let me go ahead and solve it. Okay. Now what I'll do in this particular question is I'll take 4 parts. This entire rod is now divided into 4 parts. So moment of inertia, let's say, of this part is I1, of this one is I2. This one is I3 and this one is I4. Simple understanding. Okay. Now I2 and I3, moment of inertia of I2 and I3 will be the same because they are symmetrical about the point of rotation out here. Oh, fine enough. So we can write here I2 will be equal to what? I3. That is my first equation. Okay. Next, we can see that I1 and I4 is again the same, right? So we can see here that my I1 is equal to I4. Second one, now we will go ahead and calculate what is the value of I1 and what is the value of your I2. Simple enough. And then we can go ahead and add the moment of inertia of all of them together to get the moment of inertia about this point. So we know that moment of inertia of this entire figure about this axis of rotation will be equal to I1 plus I2 plus I3 plus I4, right? So what will be equal to I2? I2 is just one rod of length L and this is about one of its ends. So this one is very simple. I2 is nothing but ml square divided by 3. Clear? Now there is a little bit of a challenge to calculate your I1 or I4, but with the parallel axis theorem it is easily solvable. There is no difficulty. Fine. So let's say we know that this angle will be equal to 90 degrees. This angle is given to us as 90 degrees. Now we take one point from here to the center of this rod. We take the distance from this point to this point. This is, let's say, your D. Fine. Because we need to find out the moment of inertia about this point. But for this rod, it is not directly connected to it. So what we will do is, we'll find out the moment of inertia about its center of mass. So I1 will be equal to ml square divided by 12. What is this? ml square divided by 12. ml square divided by 12 is the moment of inertia of this rod about its center of mass. Fine enough. Now, we also need to apply the parallel axis theorem. So we need to add a term, that is md square. Now, what is your md square? Just a second. What is your md square? Let me just rub off this m and replace it by my capital M. Now this d, if you look at this triangle, call it as your ABC triangle, we can see this length from here to here is L by 2 and this length is actually L. So d square will be L square plus L square divided by 4. Simple idea. So this will be nothing but 5L square upon 4. Is this clear? Now, what we need to do is calculate your I1. I1 will be equal to simply ml square by 12. ml square by 12 plus md square, that means m into or 5 by 4 ml square. Fine enough? 5 by 4 ml square. What do you need to do right now? It's very simple, isn't it? You just need to add it up. So how much will this be? See, you can take 12 as the LCM. You can take 12 as the LCM. This will be ml square. 4 2 times 2, 10 times, right? So this will be nothing but equal to 11 ml square. 11 ml square. Now, I don't think it is a very difficult problem. Okay, you can easily get it. Answer will be option B. I1 you got it multiplied by 2 times because I1 plus I4. I2 you got it multiplied by 2 times and you will get your answer as option B. Very good, Mitesh. Not just Mitesh, I think Anush, Abhishek, Ravish, everybody has actually solved the question. Alright, fine students, now let's move ahead to the next question. Now the next question is a little challenging, alright, but I'm going to give you a formula which can help you in your examination. There is a standard formula for it and I will also tell you the methodology of how we actually derive that particular formula. Okay, so we are not taking up very standard questions of your moment of inertia, but yes, something which I think can be very useful for you students. Okay, now in this question, as you see, what do you see? It's a rod. So for a rod, if we are taking an axis passing through its center of mass or through the end of the rod, it is very simple. It is ml square by 3 or ml square by 12. But here there is a little bit of a challenge, if you see here. Okay, what is the challenge? Now this rod is in this direction, alright, making an angle of 30 degrees with the vertical axis. And it is rotating like this, like it is forming a cone. Are you able to visualize it? It is like forming a cone. So we need to find out the moment of inertia of this rod about this axis. Now there is a little bit of a challenge. In this question, because if you observe very carefully, then from the axis of rotation, if you take different masses, let's say this one, or let's say this one, or let's say this one, they are at a different distance. The distance is not constant. So we need to integrate. The idea comes that I need to integrate. I need to take small parts and integrate the entire thing. All right. By the way, I see Mitesh has already answered this particular question. Also, he says it is C. Well, Mitesh, let's have a look at it. But I am going to give you a straight cut formula to actually do this question. Okay. The formula is moment of inertia of this particular setup is 1 divided by 3 ml square sine square alpha, where alpha is actually this angle. Okay, so you can take it as 1 divided by 3 ml square sine square 30 degrees. All right, I think it's pretty simple. 1 divided by 3 into ml square Sine square 30 will be 1 divided by 4. So this will be 1 divided by 12 into ml square. Awesome, Mitesh. Mitesh, where are you from? Which part of the country? Himanshu has also answered this. Himanshu Kumar, very good. You have done it correctly. Now, students, are you eager to know how did this derivation, how did this formula come? How did this formula come? Are you eager to know this? Okay, fine. I'll tell it to you. How did this formula actually come? Awesome. So, let's go ahead very quickly without spending much time. Let's do this question in a integration method. Okay. See, a similar question might come. Maybe in this orientation they have presented a sphere. So you should know how to do it in the examination at the same time. Okay. So how do we do it? We take a small element. Let's say it has got a mass of dm. We take a small element which has a mass of dm. This I will treat it as my x-axis, and let's say this is at a distance of r. Okay, so I can say that r will be equal to your x sine 30 degree. Now here 30 degree is given, but it can be general angle alpha. All right, so let me do it with a general angle. Let me do it with a general angle. Say it is sine alpha. Fine. Now what is the total mass out here? M. And what is the total length? L. Right? So what will be your dm equal to? Dm equal to will be mass divided by the total length into dx. Let's say the length of this portion is actually dx along the x-axis. Fine. So dm will be equal to m divided by L into dx. Then what will be the moment of inertia of this much portion only? The moment of inertia of this portion will be dm into r square. When you need to find out the net moment of inertia, just integrate it, and you will get integration of dm, that is m divided by L into r square. R square will be x square sine square alpha into dx, integrated from 0 to L, and you will get ml square divided by 3 into sine square alpha as the answer. All right, did everybody understand this? Fine, give me a like if you have understood this particular problem. Give me a quick like, students, if you have understood this problem. It is not very difficult. Remember, whenever mass is varying, whenever distance is varying, the first thought that should come to your mind is that of integration. All right, chalo, now let's go ahead to the next question. Now the next question, let me tell you, it seems to be one of the favorites of the examiners who sets the paper for your JEE mains. Okay, why? Because either one of a similar kind of a question is going to come for center of mass or for moment of inertia, and for 2018 paper, 2019 paper, we have seen that a similar kind of a question has been there. So why not? Let's practice it in the final moments of our preparation. So what do we have here? We have got a disc. What do we have here? We've got a disc. Okay. Now this disc, from this disc, now this disc has got certain properties. It has got a mass of 2 kg. It has got a radius of 4 meters. All right. Now from this disc, a smaller portion of it is taken out. All right. So this has got a radius of 1 meter. This portion has got a radius of 1 meter. And the center of this portion is 2 meters from here. I need to find out the moment of inertia of the remaining portion about an axis which is passing through this point, and it is perpendicular to the disc. Right? How do we do it? Simple enough. See, whatever is the remaining portion, let's say the moment of inertia of this particular portion about this axis of rotation is equal to your I1. Okay, and the moment of inertia of this portion about the same axis of rotation is equal to I2. Then I can say the moment of inertia of the entire complete disc about the same axis of rotation will be equal to I that will be equal to I1 plus I2. But what do we need to find out in the question? We need to find out your I1, that is of the remaining portion. Alright, this one is a standard which we already know, that is mr square by 2. Alright, so I1 will be I minus I2, right? I is mr square divided by 2. Okay, the mass is how much? 2 kg. It is given to me. Alright, so how do we calculate your I2? So the next challenge is calculation of your I2 about this axis of rotation. Again, parallel axis theorem. I told you, parallel axis theorem is used in most of the questions. If there is a question of moment of inertia is going to come in your JEE mains. Alright, so let's go ahead and calculate. Okay, the moment of inertia of this portion about this axis. Clear? So what do you see here? What will be the mass? Most importantly, the first thing I need to know is the mass of this portion. Okay, now it will be proportional to the area that they actually cover. Now this entire area, let's say if I take it as your A, clear, what will be the area of this portion? Let me call it as my small a. Alright, so capital A is pi into 4 square and small a will be pi into 1 square. Their radiuses are given to me. So I can see radius of the bigger disk is 16 times the radius of the smaller disk, which implies the mass of the bigger disk will be 16 times the mass of the smaller disk. Indirectly, I can say mass of the smaller disk will be capital M divided by 16 or 2 divided by 16, that will be 1 divided by 8 kg. That means this portion out here will be having a mass of 1 divided by 8. Is this clear? Now we'll go ahead and find out the moment of inertia of this portion about this axis of rotation. Okay, how do we do it? Simple enough. Let me take it as small m only. So moment of inertia about this axis, about its center of mass, will be equal to how much? M into 1 square divided by 2 plus M into this distance is how much? 2 square. So that's what it is. So this is your I2. So I can write your M as 1 divided by 8. It will be 1 divided by 8 into 1 divided by 2 plus 1 divided by 8 into 4. Clear? So this can be written as simply nothing but let's say I take it as your another 2 and 2 here. So this will be 9 divided by 16. Okay, 9 divided by 16 is the value of your I2. Okay, so go ahead, calculate this. Let me go back to the last page. So here mr square minus, how much did we have here? 9 divided by 16. So this will be 9 divided by 16. Mass is 2, radius is 4. So 16 divided by 16 square divided by, by the way, not 16 square, it is 4 square. So it will be 16. So it will be 16 only divided by 2 minus 9 upon 16. Okay, so we'll take 16 as the LCM and we'll get, now calculation, something that I don't want to do. All right, option D is the correct answer. Wow, this is awesome. My students, you guys are rocking in the class. All right, I can see so many names who have given the correct answer here. Mitesh, Sarthak, Ganesh, Ravish, Himanshu and Mitesh, and again the same names got repeated. Okay, so guys, I hope you are enjoying the session. You are having fun in the session, learning these very crucial questions at the last moments of your preparation. And if you are enjoying it, do not forget to press on the like, share and subscribe. So let's go ahead to a set of more interesting problems, all right, for this session. So what do we have here in this? Let's see. Now this is more of a conceptual. See, pure rolling has always been some amount of a pain area for a lot of students who are preparing for the JEE. All right. So here in this question, they have told us that this is a bigger disk. All right, this is a cylinder. This is a cylinder. Sorry, it's not a disc. So this is a bigger cylinder. This is a smaller cylinder. They have got a plank on top of them. They have got a plank on top of them. The smaller one, the center of mass, is moving ahead with a velocity of v. It's moving ahead with a velocity of v. What will be the velocity of the center of mass of the bigger disk? That is the question. Okay. So can I see some answers coming up on the chat box? Can I see some answers coming up on the chat box? Students, today's session is going to be really enlightening for you students. Okay. So chalo. Let's go ahead and see how do we solve this particular problem. We know one thing for sure. Let me tell you the concept behind it. All right, for rolling, all pain areas of your rolling motion is going to go away. Okay, see, simple thing. If I have a surface and on top of it, let's say there is a rigid body which is kind of rolling. It's kind of rolling. All right, velocity of the center of mass. Velocity of the center of mass is basically, this is point A, VA. This is point B, say VB. Then velocity of center of mass, use this formula. Okay, your life will become very, very simple. That is your V relative divided by 2. That is a formula that you can use to quickly find out the answer without even thinking anything. All right, in every rolling motion, pure rolling motion of rolling without slipping. All right, that is your pure rolling, isn't it? So how do we calculate it? V relative in this case. This is at rest. Let's say this one is moving ahead with a velocity of, let's say, V1. So V1 plus 0 will be equal to V1 plus 0, V relative, all right, divided by 2 will be equal to V, which implies V1 will be equal to 2V, right? V1, the top portion, will be moving with a velocity of how much? 2V, all right. Now, there is no slip out here for this also. Right? So this point velocity and this point velocity should be the same. So this will also be moving ahead with a velocity of how much? 2v, right? Then the center of mass here will be moving ahead with what velocity? 2v minus 0, because this is at rest. All right. So 2v minus 0 divided by 2 will be equals to v. Fair enough? Simple enough, all of you? Did everybody get it correct? 2V is not the correct answer. Correct answer is option B. That is, Himanshu has got it correct. All right. Himanshu, good job. All right. So, did everybody understand how do we calculate the velocity of the center of mass? That is the relative velocity of the topmost point with respect to the bottommost point divided by 2. Finished. Okay. That is the formula you need to remember. And you can crack any of the questions of these kind of questions which appear in the examination. See, the next question is something of this sort. Same formula we are going to use. All right, let me explain to you. What does this question tell me? Okay. Now, in this question, we have got a set of 2 cylinders. On top of it, there is a plank. On bottom of this, there is a plank. And there are 2 more cylinders and they are resting on the ground. Now, this ground is stationary. This ground is stationary. It is not moving. The ground is stationary. All right. Now, if these are moving in this direction with a velocity of 2v, this will have an angular velocity of, let's say, omega 1. And these are moving in this direction. So, this will be rolling like this with an angular velocity of omega 2. What do we need to find out in the question? We need to find out what will be the value of omega 1 divided by omega 2. This is my question. I hope all of you understand it. Now, how do we do it? Should I give you the shortcut formula? Should I give you the shortcut formula here? Okay. Yes, we can do it by a simple formula, that is omega of rotation is equal to, let me just take it off, will be equal to V relative divided by 2 times R. All right. या फिर I can say omega will be equal to V relative divided by V velocity of the center of mass divided by R. All right. So in the last question, we saw how to calculate the velocity of the center of mass if the velocity of the topmost point and the velocity of the bottommost point has been given to me, right? Now we are looking at how to calculate the angular velocity. All right. So angular velocity will be simply velocity of the center of mass divided by r. Okay. So let's see this now. What is for the top one? This is going with 2v, right? This is going with 2v. So we will calculate it. Let's say we'll take some fresh page here. So here we'll calculate your omega 1. Omega 1 will be equal to 2v, right? 2v minus of, what is the bottommost point? This point will be going in this direction with a velocity of again v, right? Then what is the relative velocity of the topmost point with respect to the bottommost point? 2v minus v, because it is going in this direction, right? So it will be 2v minus v divided by 2 times capital R. Achha, students, all these cylinders are basically identical. All these cylinders are identical, right? So they will all have the same radius. If they were having different radius, the question would have been more challenging. Maybe we can call it for the advanced level, right? But now let me look at from the JEE perspective only. Okay? So what will be this value? This will be 3v divided by 2r. Similarly, we will calculate your omega 2. What will be your omega 2? Now see, the topmost point is having a velocity of v in this direction and the bottommost point is stationary. So what will be the relative velocity of the top with respect to the bottom? It will simply be v divided by 2r, which implies your omega 1 by omega 2 will be equal to 3. Alright, let's see now how many of you have actually got it correct. Let me look at the chat box here. Option B, so Mohammed Qasim, Abhay Gupta, awesome guys, you have done it correctly. This is pretty cool. Jigar Shah has also done it correctly. Now other answers are also coming. So this is superb. Guys, did you enjoy this method? Did you learn something out here? Yes, if you have learned this, do not forget to press on the like, share and the subscribe button. All right, students, let all the other people, let all the other janta across the nation spread the news. All right, students, you might be knowing that most of the channels today are basically giving out lectures in Hindi only. All right, but across the nation there are like so many different places. Look at the northeast, look at the southern part of the country, all right, where the students, they would want to learn on such a platform like YouTube, all right, that too free of cost, and have the exposure to such valuable problems in the last minute of their preparation. So do help out each and every student by spreading across, by clicking on the like, share and subscribe. Okay, definitely share much. Let it go out to as many students as possible, your contacts, your neighbors, everyone. All right, so let's go ahead and check out the next problem. The next problem, I've kept it pretty similar, because yes, rolling motion could be a tough part, rolling motion could be a pain area. All right, so pause your screen now for 2 minutes. Pause your screen now for 2 minutes, because if you're watching it in recording later down the line, okay, and solve it. And then only you will go ahead in your lecture. Let me tell you, students, the amount of confidence you will have after you have solved this kind of problem will definitely lead to a better score in your JEE. All right, see, try and understand, this is a very similar problem. We need to find out the angular velocity, right? It's so simple, right? So go ahead, test yourself and then only move ahead. Fine. So what do we have here in the next problem? Next problem is to do more with the dynamics of rotational motion, right? It is the dynamics of rotational motion. What is it that we mean by the dynamics? Like in your Newton's law. See, students, let me tell you, if you have to really master your rotational motion, if your understanding of Newton's law is good, it is just the replica out here. We know there are like so many analogies. Force is equal to torque, velocity, angular velocity, moment of inertia, mass, angular momentum, and things like that. So if you have got a good understanding of your Newton's law, this chapter should not be a problem for you. Alright, however, let's look at this problem and let's try to find out what is being asked here. There is a rod here. The rod is of length L and it is hinged not at the center, but at a distance of L/4 from one of the end. And here at this point, they have not specified which point specifically, particularly, but this point here is being connected to a string. Right. So what they're doing is they are in the future. I'll go with a string. I'll go with a scissor and cut this string. All right. What is going to happen? This string, this rod is going to have rotational motion about this hinged end. Right. Then the question that they have asked is that just when you have cut the string, tell us what will be the acceleration of point B, okay, and the reaction at the hinge. So these are the two things that we need to find out. So here again, this is more of advanced multiple choice question. Let me not say advanced, it's more of a multiple choice question. The concepts are pretty simple. All right, it's also for the JEE mains level. Okay, so let's go ahead and find out that what will be the acceleration of point B. Okay, so let's try and understand this. So once you cut this particular string, so students, are you ready? People are already giving the answers. Yes, it is correct, Himanshu. It seems that you're pretty quick in your solving. Good job. All right, so we look forward to a very high score by you in the April mains as well. Okay, by the way, how much did you score in the January paper? Okay, hi Shakti Singh, hi, how are you doing? Which part of the country are you from? Okay, so should we get started? All right, so what do we have here? You cut it, right? Then what are the forces acting? We have the reaction here, the hinge reaction, fine enough. Besides that, we will have the mg here. Mg will be acting in the downward direction. Now you have cut this. Now you have cut it. Tension has become equal to 0. No other forces are there. Okay. Now we need to do what? See, for all these dynamics question, we need to have, see, we had equilibrium where the net force was equal to 0. Okay. Or if the net force is there, it is mass times acceleration. Here we need to find out the net torque. Is it balanced? And if it is balanced, okay. If it is not balanced, then what should be the value? Okay, so we will see mg will create a torque about this point. What will be the value of the torque? Mg into L/4, right? Mg into L/4 is the torque because mg is acting in the downward direction. Torque about this point here. All right, so this is equal to what? I alpha, right? Net torque, because mg is the only force which is going to create the torque out here. So mg into L/4 is equal to I times alpha. Now what is the moment of inertia of this rod? And about which point should I find out? It is rotating about this point. So I should find out the moment of inertia about the axis passing through this point. I know the standard. Through the center of mass, it is ml²/12. All right. About this point, about this particular point, it will be the usage of the parallel axis theorem, right? So how do we do it? Simple enough. So moment of inertia about this point, call it as O. About this point O will be IC plus whatever is the mass. Mass is mass M. Let's say we'll take it as mass M only. Okay. So mass M d square, where d is this particular distance. All right. So what is about its center of mass? ml² divided by 12 plus m. D is how much this distance will be? Now from the center to this A will be half the length. So this is L/4. So D will also be L/4. Simple enough. So I'll take L/4 whole square. All right. So this will become how much? See, ml² divided by 12. All right. plus ml square divided by 16. All right. So this is what we have here. Can I take the LCM? Yes, I can take the LCM here as 48, 12, 4 times 4 ml square plus 16 into 3 times 3 ml square. So this will become overall 7 ml square divided by 48. Now only calculation is left out. Okay, so this can be written as equal to. Can we take it to the next page? Yes, let's go ahead and take it to the next page, students. All right. So mgl by 4, I can take mgl by 4. So this was the torque which was created due to the weight of the rod. Okay, is equal to 7 divided by 48 into ml square. That is I, right, into alpha. All right. So let me see what all things I can cancel. M and M will get cancelled, 1L will get cancelled. This will go 12 times, so alpha will be equal to 12G upon 7 times L. Now, what has been asked in the question, that is just after I cut it, what is the acceleration of this point B, right? What is the acceleration of point B? See, acceleration is equal to nothing but R alpha. What is R? R is this distance from here to here, and that is 3L divided by 4. Okay, so acceleration here will be 3L divided by, excuse me for this, let me rub it off, 3L divided by 4 into alpha. Alpha is 12G, 12G divided by 7 times L. Okay, 4 will cancel it by 3 times. This will be equal to L cancel, 9G divided by 7. All right. So let me see the answers. Yes, correct. Mohammad Qasim, your answer is absolutely correct. Okay. The answer is option A. Option A. By the way, options are not here. 9G divided by 7. Yes. Option A is the correct answer. All right, students. That is the end of today's session. Now here, let me not call it as the end of today's session. You can also find out the reaction at the hinge. It is also not very difficult. These were some of the questions that I had taken. Now here, this question is kind of very similar. So I planned today that I'll be taking up one question, explaining it to you, and the second question I'll give it to you as a practice for your homework. Okay, so let's say this is your homework question. Students, let's interact over the comment section. Okay, so if you're watching it live, that's good enough. If you're watching it in the recorded format, what do? Solve it. Write your answer in the chat box. Okay, so we know how many students are actually serious about these sessions, how many students are actually taking this serious, taking these sessions very seriously. All right, because if you are benefiting, because ultimate purpose of us people is that we should be of service to you guys. All right, and if you are benefiting, then why not let us know that yes, we have solved it, and we solved it like real quick after we watch the video. All right, so students, now answers have already started pouring in. Okay, superb guys, superb. All right, so here option C is the favorite. People are going for option C. This is superb. All right, so L divided by 2. That means the point which will be having an acceleration of g. All right, the point which will be having an acceleration of g. Okay, pretty simple enough, isn't it? Chalo, smart people, I must tell you. Now let me also finish off with this question. This will be our last question for today's session. Now what is here? Now this is a question on rotational equilibrium. All right, on rotational equilibrium. If anybody is solving it on the fastest finger first, is there? I'm going to take a separate session on the April strategy. By the way, yes, let's go ahead and solve it. Rotational equilibrium. Okay, A lot of questions are based on this particular topic. What do we mean by rotational equilibrium? Rotational equilibrium means net torque is some demo lectures and things like that. So you go ahead and check out the lectures. Try and understand the value, the quality of the lectures. If we are able to give this much quality, YouTube, just imagine what do we have there for you on the Plus platform. I mean, there is a plethora of problems which are being done in a very organized manner. The concepts are being taught in a more frictionless manner, I would say. All right, so that as it comes from the teachers, it's like, you know, so smoothly adopted by the students. Mostly why try and understand. When you actually go to the classroom, there is so much of chaos. There is so much of like, you know, if one concept is being taught once, all right, it's like, you know, it's over. I mean, like, you know, there are so many students. I'm talking about an offline class, but here you attend a live lecture, you just get the recording after it. Okay, if you haven't understood anything, right, let's say there, you can watch it again and again and again and ask the doubt in the next class in a live interaction with the educator. All right, now students, other important things that this platform is there to offer you are the live polls and leaderboard, which actually makes the session so very interesting. If you have to gain an experience of it, you must log in today to the Unacademy channel and get a taste of it. Without tasting it, you will not know that what you are actually missing in your life. Let me tell you, like, you know, I am from IIT. If there was something, I cleared my IIT, and if there was something of this sort in those days, all right, blindfoldedly have actually taken it. Okay, now here I have the test series and the analysis, which is definitely, like, you know, there in most of the services that has been given to you guys. Live doubt clearing sessions. In the live doubt clearing sessions, all you need to do is take a photograph, click a photograph of whatever doubt book. I usually have a recommendation for you students. Use the app called Cam Scanner. I'm writing it down for you students. Okay, it is called Cam. Okay, SCANNER. All right, now there is a setting called magic color. So it's like, you know, a very clear print of the doubt comes to the teachers, and there it goes right away to your solution box. Okay, and the next thing, undoubtedly one platform, one subscription, and more than 100 educators on a single platform. What else do you need? It's a university. It's an online university. It's not just a platform where you get so many teachers on a single platform. Why wouldn't you want to go for such a subscription? Right. Now, moving ahead, students, what do we have? Subscription. That's the next stage. And once you have done it, use the code SMLIVE. All right. Students, using the code SMLIVE will give you an instant discount of 10%. Okay. So, importantly, SMLIVE is the code that you are supposed to use for the Plus subscription to get right away a 10% discount. Students, very important slide. Okay. Subscribe to the channel if you're visiting it for the first time. Why exactly? Try and understand. Subscribing will give you access to the future notes, doubts, discussions that we have on this particular channel. And let me tell you, we are coming up with like so many interesting things. All right. I mean, the JEE English channel is going to come up with so many brilliant things by the JEE English team. Now we have a dedicated team for this particular channel for physics, chemistry, mathematics. All right, so we are going to have lots of interesting things. Okay, like in the next week onwards, I'm going to start off a series of puzzles. Now, why a series of puzzles? Try and understand this concept. Okay, see, puzzles, they actually make our mental thinking very strong. Okay, we are so used to study concepts and then, like, you know, just write those concepts and learn the concepts or learn the formulas and apply it. But what are you missing out there? You are missing out on the application of your mind to actually think about a concept in a different way. Okay, so that is what we are going to have it from the next week onwards on the JEE English channel. All right, that is, you will be having a discussion of those puzzles right here on the channel. So why would you want to miss out on such important things, right? Now here, just after the sessions, you will get a PDF document of the entire lecture. All right, so that you can revise it later, that there will be a link and you can just download it from there. Okay, do not forget to press on the bell icon, because anytime we have an important session coming up on any aspect of JEE, all right, like today we know that the dates for JEE paper, the registration of the JEE has been extended. All right, so that actually came up in the channel, so it should go out immediately to you students. All right, now just a second, and finally we have JEE English channel. There are other sister channels like NEET, JEE Foundation, and besides that, students, if you have not subscribed to the Unacademy platform so far, all right, right away use the code SMLIVE and get a 10% off immediately. All right, thank you and God bless you. Best of luck, and remember students, stay safe, stay healthy. That's very, very important just before the JEE examinations. Drink a lot of water, because these days it's getting summers in most of the parts of the country. Keep yourself hydrated, get proper sleep, don't eat outside, and just maintain these golden thumb rules before your examinations and have the confidence within yourself. Yes, you know that you can do your best. All right, thank you and bye-bye.